Hi, hello. Nice to see you all here. Thank you so much for coming out. My name is Aidan Hyman. I'm a co-founder and CEO of ChainSafe Systems. We're a blockchain research and development firm based in Toronto, Ontario. And today I'm going to be talking to you all about why, for us, Polkadot really matters and kind of the problems that we've faced in building out a lot of the infrastructure that we have over the past year and a half, 2 years, and why Polkadot kind of alleviates a lot of the cumbersome kind of paradigms that something like the Ethereum virtual machine kind of forces us into. So yeah, hello. If anyone wants to send me an email and talk to me about this, yeah, please send me an email. It's aidan@chainsafe.io. So yeah, just a little bit about us. So I just wanted to talk about a few of the projects that we're extremely proud to be working on. First to start, Lodestar. So Lodestar is a TypeScript implementation of the beacon chain, and there are multiple components to it. So the beacon chain, for whoever doesn't know, is phase 0 of the ETH 2.0 roadmap. So it's kind of this piece of software that will coordinate stakers for now, and eventually also then coordinate shards and things like that. So yeah, there's a couple really cool libraries we're working on, maybe really cool depending on who you are. All in JavaScript, so if you're kind of a developer in the kind of higher end of the stack, there's some stuff here that might become useful for you as you kind of migrate over to the ETH 2.0 world. Gossamer, which is why I'm really here today, which is the Golang implementation of the Polkadot runtime environment. And this is basically a piece of software that will allow developers to build out parachains. And parachains are basically kind of within the Web3 world, and it's something that kind of we'll go into a bit later. It's this kind of new look at what a sidechain can be, or something that has shared security guarantees, but still very specific use case for maybe what it's trying to achieve. And then the Girly testnet, which is a cross-client proof of authority testnet that we started at ETH Berlin, and has continued to be worked on not only by us but by the community, and is now one of the more widely used testnets. That's a weird thing. And then Chainbridge, which is something we in our work previously have used a lot. And basically this is a modular cross-blockchain bridge which allows for arbitrary data transfer from one blockchain to another. So as I will talk about the work we've been doing on sidechains, a piece of software like this bridge really is what allows something like a sidechain to basically interoperate with the rest of the blockchain world. So without that, it would be pretty useless. And then, yeah, a bit about us and how we got here. So about a year and a half ago, we really started looking at, and yeah, so we're a blockchain research and development firm, so we work with clients and we're there to really solve their problems. And we started to see a lot of interest in sidechains as a kind of pragmatic, horizontal way of scaling right now. And what I mean by that is that it's not a layer 2, it's not like layer 0 on the networking side, we're not making many changes, but we are kind of creating a whole nother layer 1 just for this kind of application-specific use case. And I'll talk a bit about kind of those 2 examples that we've worked on, and through those examples I think it'll become really clear why Polkadot not only makes sense but solves the problems that a lot of our clients kind of faced in trying to build a blockchain. So sidechains, what is that usually? What is that? So traditionally sidechains are more to do with merge mining and kind of colored coins and doing a whole bunch of weird stuff, but that's years ago, before most people even cared about blockchain. So in the context of kind of contemporary sidechains, usually what that means is it's forking Ethereum, and then kind of optimizing it for a use case. It could be higher transactions. It could be some kind of specific opcode for whatever need be, a precompile. It could be a whole bunch of different things. But the idea is that this sidechain only becomes really relevant to the rest of the blockchain world through a bridge. And really, it's those two pieces together that allow for a sidechain to exist. And so what is a bridge? So it's really simply a deposit and withdrawal contract with a bridge instance sitting in the middle, interacting with both of those contracts. And it could work vice versa. The deposit could be on the other side and the withdraw on the other. So basically, if you have a token, and that token could have financial value, it could have some kind of arbitrary data held within it, this piece of software allows you to basically mirror it on the other side. Now there's a lot of kind of issues with the decentralization of something like this, and a lot of work being done by teams like ours and others to really decentralize this process. That could be done through something like a proof of stake type mechanism that sits on top of the bridge instances and creates this incentive layer for people to operate these bridges. It could look like many different things, but that for us is how we see that process kind of evolving. And so then just to go to the use cases that we've been working on for the past year and a half. So one is a local community governed blockchain. And it sounds like a mouthful, but it's really an exciting project that 20% of the city I'm from, in Toronto, 20% of the city uses this project. And over 200 stores accept the token. Over $1.2 million has been given out to users to spend in-store. So basically the largest stimulus package ever given to the city of Toronto by a blockchain project. And so what were the requirements for this project? So, we'll try and keep it simple, but basically, it looks like something like a unique consensus mechanism, because in this case, we wanted the store owners, or at least the project intended for the store owners, to be the major validators of this network. The users themselves didn't necessarily have the same stake in the game, so that's how kind of this was designed. Oh yeah, okay, I have that in more detail. So the idea was a kind of permission proof of stake. So, this idea of proof of stake, but only that, these store owners would be able to actually be stakers, and also then run a node itself in store. So the stores would stake to then validate, obviously, this network. And they handle transaction fees so that kind of like meta transactions, but it's all done within kind of a different layer. And then also the consensus is maintained through the economic incentive of knowing that one store and another store might be using this token to pay up to 30% of their bills. They really don't see any value in double spending against another store because that would jeopardize all the tokens that they're receiving, and they could get slashed for it. And so interoperability, our second requirement, because really not that many people outside of the city of Toronto were using this project. And so we wanted to ensure that this token is usable so people could potentially create other forms of this kind of community-governed blockchain, but in different ecosystems. So again, the bridge came in handy here, and it was deployed and used to transfer these ETH tokens to these ERC20 tokens to the Ethereum mainnet. And then obviously high transactions per second, with 20% of our city using this. We needed people to be able to use it. It speaks for itself. And so because of this more trusted setup, we were able to do certain things to optimize how many transactions per second we could get, given the security guarantees that we were looking for. And so what did we actually have to do to make all of those requirements happen? So we forked Geth, which is usually what we do in this situation, and we forked the parity bridge. And in this case, this was actually the inspiration for why we built our own bridge in Go. Because in implementing and shipping the parity bridge, our client returned to us and said, wait a second here, we don't write Rust. Do you expect to be writing code for us for the rest of our lives? And that was a good reality check to realize that, yeah, for us as developers, working in this emerging, exciting technology, things like Rust are really, really exciting, but for an average developer in an enterprise, it might not be too usable. And so that's why we built our Bridge and Go, is basically to solve this client's problem that we didn't really know even was a problem until we dealt with it. And then we obviously needed to implement a unique POS consensus mechanism. And so what did we learn from all of this work? Well, basically there is a huge need for more modular consensus mechanisms and the way kind of blockchains are built to be able to swap consensus mechanisms for one another. Now, parity Ethereum does this pretty well. Geth is becoming more and more modular every day, but there's still a lot of things bundled there that we might not really need to solve our problems. And another thing that was a huge lesson learned for us, coming from the ETH community since the beginning and being a group of people who met at the meetups and then built a company that was just trying to do the things that we enjoyed to do every day, which is hybrid models are necessary for scale. We do not need proof of work or an exact same kind of idea of proof of stake to work for everyone for this technology to make sense. If anything, and things like Polkadot show this, a need for different consensus mechanisms to interoperate with one another and complement one another, allowing for different use cases to exist, is clearly the way of the future and is clearly, in our kind of view, based on the work that we've done, where the technology is going. Because this is what people are asking us to do, and it's being used by users. And also a local blockchain can be successful. That was very shocking as well, because we think of blockchains as decentralized, kind of stateless pieces of technology. But in this case, a local community was able to really bootstrap a somewhat incredibly successful project that isn't really seen outside of that geography. So that was a huge lesson learned. And again, all of these kind of lessons learned really, I think, illustrate why something like Polkadot makes a lot of sense for this future where we are building blockchains to solve problems as opposed to writing smart contracts to solve problems. So example 2, interoperable attestation network. So what the requirements for this were to allow for proof of attestation from one kind of trusted source to another through an opcode. So this meant actually implementing an opcode in the EVM, dealing with the compiler, with the new version of Solidity, doing all these things just to allow for this proof of attestation to happen. So an incredible amount of work just to do something that might have been a lot more maybe it would have solved the problem better if we were able to purely focus on application logic and not have to worry about a technological paradigm in which we have to deal with precompiles or opcodes, and that's the only way to make changes. Oh yeah, I keep on forgetting I have the continued slide. And the really exciting thing here is that this was the first time in all of this work that we had done that we were able to do something for a client and then bring that code upstream. And the only thing that we were able to do that for was for Remix, adding Control-C to the IDE to actually recompile as opposed to save. So basically nothing. A minor UX update after a year and almost a year and a quarter at this point of work building open source technology. So we're saying it's open source, but at the end of the day, it really is siloed to that specific project and not really usable by people in the outside world. And so then for this unique consensus mechanism, we looked at auth-hash. So auth-hash is like a permission proof of work. So it's very interesting and very unique. But yeah, proof of work was chosen at the end because it just made a lot more sense. And then this network, it required to interoperate with a multitude of networks. And this meant transacting that opcode or the attestation through the opcode to multiple blockchains. And yeah, this was not native to the blockchain, and so the way that we would handle that on the other blockchain was a bit cumbersome. And yeah, this all required a bridge that could actually pass that specific attestation and handle it on the contract side as well. And so yeah, what did we have to do? We had to build a bridge that passes attestation data. We had to fork Geth. We had to implement a unique consensus mechanism, which wasn't used. And so what did we learn from this? We learned that there's, again, a need for more modular blockchain components. We should not have to introduce an opcode and then deal with the repercussions of that up the stack just to do something that solves a problem in a relatively kind of simple kind of scope. Hybrid models are possible. Things like auth hash were quite interesting to look at. And I think the most important are the last two, which is the only upstream PR was for Remix, and that was just adding Control S. After all of the work that we did, and it's all open source, you can see it on GitHub, that's all we were able to contribute forwards. And that to me is kind of the biggest problem that we face in the Ethereum space, is that so many, or just in the blockchain space in general, is that so much of this work is siloed and not able to not only interact with one another, but also to be used by one another, because there isn't kind of this framework for how we build things. And so yeah, in my opinion, interoperability is only as useful as it is usable. Interoperability on a token level is very different than on a developer usability level. We need developers to be able to use these components, not only contribute to the ones that we're building, but also to collaborate on implementing them in other use cases. And that to me is why Polkadot is so exciting. The idea of parachains are so exciting, because we're using this framework, and through using this framework, we're able to build these components in a modular way that can then be maintained by not only a larger community, but can have larger kind of impact within the wider developer community. This is huge, because open source is not just marketing. It's not just about saying, hey, we're great people, we're altruistic, we're open source. It's usable. It has to be useful. And that's why open source has traditionally won, not just because they put a label on it, but because people use this stuff. And that's kind of what I see as being the big problem that we're dealing with, is that we are building open source code, but it's really siloed off in a world that will never be seen by anyone. And so I'm just going to talk a bit about Polkadot. I don't have much time left. And what I see is misunderstandings from not only the community, but also just to note, I'm taking all of this information directly from the white paper. If you haven't read the white paper, I highly recommend to read the white paper, because again, everything you're going to read in the next 4 slides is quite literally copy and paste. So yeah, Polkadot is a vision for a heterogeneous multi-chain framework. So just to kind of differentiate that from Ethereum, Ethereum would be a homogeneous sharded network, meaning every shard is somewhat exactly the same, whereas in the heterogeneous kind of idea of things, each of these parachains are unique and can do very unique things. So one exciting thing is Ethereum as a parachain. So imagine a world in which we're able to interact with a multitude of different blockchains through one generalized smart contracting platform. And you can, understand, you can see what's going on in these different blockchains, and as such, have transactions executed, really whatever it is that you want. But Ethereum as a parachain, and really any blockchain as a parachain, as with Bitcoin, these are kind of the things that we see as being, what Polkadot really offers, which is the ability to trustlessly interact with a multitude of blockchains, which we believe is kind of the path moving forward that is necessary to do a lot of the things that we were talking about that we were doing, but in a way that's baked into a protocol, so that we're no longer having to worry about bridges because it's built in. We no longer need to worry about just networking are an insane amount of things that we have to concern ourselves with because Gossamer, our implementation, substrate parities, implementation of, PRE, they do a lot of that, the heavy lifting for you. And so there's just a couple more things that I thought were important to note. Is Polkadot, again, this is just from the white paper, is Polkadot designed to replace insert blockchain here? Absolutely not. The goal of Polkadot is to provide a framework under which new blockchains may be created and to which existing blockchains can, if their communities desire, be transitioned. The idea here is to create a framework for blockchains to communicate with one another. A framework that allows siloed communities to focus on what they're best, which is doing whatever it is that they're doing right now very loudly, but still to be able to interact with one another because not everything is zero-sum. At least I believe so. Not everyone in blockchain agrees. Is Polkadot designed to replace insert cryptocurrency here? And again, this is just from the white paper. No. Polkadot tokens are neither intended nor designed to be used as a currency. They would make a bad currency. Most will remain illiquid in the staking system, and those that are liquid will face substantial fees for transfer of ownership. Rather, the purpose of Polkadot tokens is to be a direct representation of stake in the Polkadot network. This is extremely important in understanding where the vision of this is going, and also in understanding that this is all in the white paper, and that it's all there for people to read and actually understand the true intention here, which is to allow for these different communities to have the opportunity to talk to one another in a way that doesn't require them to really either commit fully to a partnership of some kind or to really give up their sovereignty as an autonomous network. So the idea here, again, is to bridge that, but in a way that hasn't been seen before. So this is my info, when it comes back. Aidan at ChainSafe.io is my email. I think I'm like a bit early, but if anyone wants to ask any questions, I'm going to be here until Friday as well if you want to meet. There's some time for questions. But yeah, check us out on GitHub. That's where the real things happen. Yeah, please.
Just in terms of schedule for Polkadot, is it available?
I've seen so things are still on track for launch by this year. I am not the Web3 Foundation, so I don't want to comment on Web3 Foundation matters. But there's incredible people here from the team who would love to be more specific with that, or not, I don't know. Yeah, please.
So I had a question regarding the individual chains and the main chain where they can interact. Is the main chain through the Ethereum main chain, or you have a different way of communication across the chains?
Sorry, can you repeat your question, please?
Sorry, no. So you're actually making a local chain, right, where a bunch of participants can set, and then you also allow intercommunication between the local chains. Do you make it available through the main Geth chain, or is there a different mechanism?
So Ethereum as a parachain would be its own kind of thing with direct interactions to the Ethereum blockchain, but it would not replace the Ethereum blockchain. Absolutely not. The idea is to allow something like Ethereum to flourish while allowing it to, say, execute a Bitcoin transaction based on some kind of logic in a smart contract on Ethereum or on Edgeware,
In terms of this project out of Toronto, what is the use case now? Is it still going? Like, is it still successful?
Yeah, absolutely.
How many users does it have? Like,
so they have 350,000 users, and yeah, absolutely. You can come to Toronto, and I'll take you out for dinner entirely in their cryptocurrency.
What's it called?
Bunz, B-U-N-Z. Yeah.
So if I understand correctly, so now with parachains, all the projects that you were approached that you had to solve for each individual will be easier to tackle now if you do it with Polkadot when Polkadot's out. I mean, I'm not sure, like the POA network, you need to build your own bridge. Any sidechain that you need you currently do, like you said, needs to be centralized and all that. I'm not sure if I understand. Are the bridges in Polkadot like built in, or you need to implement per parachain that bridge to whatever other network you're trying to?
So the idea is that you have kind of, so without going into too much detail, because I think I'm almost done, but basically you would interact between the parachains through the relay chain. So it would be kind of this, this piece of software that coordinates kind of the communication amongst the different blockchains themselves. So moving forward for us, what we would do is take advantage of these incredible frameworks that are out there that take away all of the need to be a networking expert, a cryptographer, all these things that not everyone is, and allow you to focus on application logic in Go, Rust, whatever. There's a couple implementations out there, and from there you're good to go. So yes, we would be using that moving forward as much as possible. Cool, I think that's it. Thank you so much. Have a good day.